Hey guys, so gold recovery. So one of the things I did when I started out with this gold recovery hobby was I spoke to all my friends, Skype, text, email, whatever, and just said, hey, if you guys come across anything, any old computers at work or anything like that, just keep them separate for me, and I'll just grab them when I see you again, type of thing. And I want to try this gold recovery thing. And I have this friend Jack, who always seems to come through with interesting things whenever I've got a weird request. And yeah, so Jack liberated from the dumpster at his work a lot of these old mainframe boards. And these are mainframe boards. Most of the chips on them are mid-1980s vintage, so 83 to 87 or so. So I'm saying that these are probably manufactured late 80s. And every single one, so I've already done a little bit of work to them, but every single one of these boards had fingers, so gold fingers, so they would slot into some kind of backplane so they all had nice gold fingers. And so I've already processed the gold fingers and ended up with about 5 grams of gold from just the gold fingers alone, which is pretty reasonable considering processing fingers is pretty low effort really. You just chop them off, and I just used the guillotine for that, so that was pretty quick. There's also a few other treasures. I'll just show you here. Hopefully things will focus. So we had quite a few. So I've removed everything that was on a socket on those boards, and you'll see a lot of these are quite nice. You got gold legs, ceramic. So these are all ceramic. Gold legs, gold covers. This is a specifically nice one. I've never actually seen one before. It is I don't think we're going to focus, but I'll just tell you it's an 80186. So I always thought it went from 8086 to 80286, but this is a 80186 made by Intel, and it's actually, so supposedly this is one of your highest yielding by weight ICs. So yeah, those are nice treasures for my little ceramic treasure box, which I've never really bothered to process. I've never processed the ceramics because I keep on stacking them up thinking that eventually I might process them, but what's probably going to happen is they're going to be worth more in 10 years than much more than the gold probably, because I've got truckloads of 486s and 386s and stuff like that. But anyway, let's move on. So what I did when I got started, so after I cut off all the fingers and processed those, is I used an air hammer to remove all of the ICs from one of the standard kind of boards. Let me get one and just show you what a standard one looks like. Standard one kind of looks like that. As you can see, lots of 74 HC logic. So zoom in a bit so you can see lots of logic. So these things are massive, by the way. This has got to be about 40 centimeters by 40 centimeters or something like that. So I don't know what that is in inches, maybe like 15 or 16 inches by 16 inches. But anyway, I used an air hammer, took off all of the logic ICs and processed them using my ball mill method, which took a long time because they're quite challenging to break up, and really extremely disappointing. Ended up with about $3 in gold for quite a lot of work processing one of those. So, and what actually happened after that is I smashed a few apart with a hammer and just had a look at the dies, and they're almost all aluminium bond wires, which is why they returned so badly. So what I've done is I've kept all the bigger dip ones, and I'm just not going to worry too much about the rest. But a fair number of these boards, like these ones, just give you a close-up, are, I imagine, the mainframe memory boards. And something that was quite interesting to me is it had these ceramic memory chips, those ones there. So they're actually ceramic chips, they're not plastic chips, and they're on a ceramic backing plate as well. And they're fairly easy to remove. And so I've started removing them. Or actually, before I started removing them, I just smashed one up with a hammer. Just smashed the top of it a little bit. And you can see there, if we can focus, that they've got a decent bit of gold brazing, and they've also, under the die, and they've also got gold landing pads. I'll put one under the microscope for you guys in a sec, so and I'll put up a couple of pictures after this. They actually do have aluminium bond wires, which is the only disappointment. But I figured ceramic stuff are really easy to process. So what we'll do today is I will pick, so those are rows of about 40 on each side. I'll break off 20 of them, so half a row, and then we'll just process those and see how they go. Okay, I'll be back soon.
Okay, so here we can see that ceramic memory under the USB microscope. This is obviously one of the ones where I've broken off the lid. And you can see, unfortunately, looks to be aluminium bond wires, but the landing pads appear to be gold plated, as well as a fair bit of gold braze under the die there. So yeah, would have been fantastic if those bond wires were gold instead of aluminium, but that's how the cookie crumbles. So yeah, we'll process 20 of these and just see how we go. If I can get even 0.1 gram out of 20 of them, and I have like 600 or so of these individual little boards, that means that I'll end up with about 3 grams in total, which is still pretty reasonable for a few hours work. So yeah, let me carry on, get these things off of their carriers, and we'll process a few of them.
Okay, so just show you, I have taken off 20 of these ceramic memory modules, including the one that I smashed apart before. And what I've decided is that if you look at the backing of them, so they're obviously 4 individual ICs that are on the ceramic backing, and it's got these tin coated legs, which I felt getting rid of that tin and base metals, especially the base metals, really are going to be a pain in the ass. So what I thought I'd do is I've just got my setup here with the let's get it going. Set up here with the standard butane propane torch. This is my old TS4000, I think, that I use for melting gold, and I'm just going to use the standard technique of basically holding on to this with some pliers, heating the chips up, giving them a tap, and you'll see they just fall off. So very easy, and because the backing is ceramic, it actually holds together really well. Sometimes when you try something like this with fiberglass, it doesn't work that well because it kind of falls apart. But yeah, so that'll just go straight in the metal rubbish bin at this point, and I'll just pull the ICs off of the 20 chips, or 20 modules, and then we'll go from there. I'll just sit back, watch some TV or something, and go through them. Okay, I'll be back when this is done. Okay, so here we have the ICs and a few capacitors from 20 of those ceramic RAM modules, and obviously to allow the chemicals to get into contact with the gold, like on that one, you have to break off these little ceramic lids, which would be a pain to do by hand. You'd spend quite a lot bit of time with a hammer doing that. So what I'm going to do is, this is not very much, I'm just going to give this about 10 minutes or so in my ball mill. That's the same ball mill that I showed on my gold recovery without incineration machines that work video. 10 minutes or so, like these things are super super crispy, super fragile. They break up very easily, so 10 minutes should open all of them up. And yep, then we'll start with the processing and see how we go. Okay, I'll be back when they're out of the ball mill. Okay, so here we have those ceramic memory chips from the 1980s mainframe board that I have just quickly run through, probably about 10 minutes in the ball mill, just to break off all the lids so that all of those gold landing pads are exposed. And because there's still quite a fair bit of tin on there, the first step is going to be get the old hot plate going and just go for some hydrochloric acid. That's going to dissolve the tin. You really have to let it get. I don't think much is going to happen when I pour this in. Yeah, so there's not much of a reaction there. You really need a bit of heat for this reaction to go. So what I'll do, you guys might be able to see there is a few bubbles happening there. Oops, see if I can zoom in for you there. Yeah, so you can see there's a little bit of a reaction happening, but really heat makes this reaction work much better. So yeah, I will let this run until there is no more reaction, which means that all the tin should be sorted out, and then we will carry on from there, and hopefully eventually we'll find some gold in these ceramic memories. Okay, so it's been an hour or so and the hydrochloric acid has run its course on the broken up ceramic memory there, and what I've done is I've decanted all the hydrochloric acid that was left, or hydrochloric acid that was in there, and the next step basically is we're going to wash the remnants out with some boiling water 5 or 6 times, and the objective here is to get rid of the stannous chloride that we created by dissolving the tin in hydrochloric acid. Some people prefer to incinerate at this point to make sure you get rid of 100% of the to make sure you get rid of 100% of the hydrochloric / stannous chloride. I have had pretty good results by just doing 5 or 6 water washes. I don't seem to have much gold going to a colloidal state, so yeah, I'll be washing a little bit. At this point I can still see by eye there's still a fair bit of visible gold, which is always nice. The aluminium as well as tin all appears to be gone, which is great. So yeah, I'll just keep on rinsing this, and then we'll move on from there. Okay, so I've washed out all of the hydrochloric acid / stannous chloride, and I have refilled the beaker there with 50 milliliters of distilled water as well as 50 milliliters of clean hydrochloric acid, and the temperature has currently risen to about 70 degrees, so I'm ready to add a little bit of nitric acid. And when I add that, the level of reaction we see will be a good indication of whether there's a decent amount of gold there. So what I'm going to do is I'm going to add the nitric acid in 0.25 milliliter increments. I don't expect a lot of gold from this stuff, so we'll see how that goes, but hopefully you guys should see a decent bit of reaction there. So about blocking the camera there. Okay, we're going to go for a 1/4 milliliter, 0.25 milliliters of nitric acid. That's concentrated 70% nitric acid. And it's been added, and there's not that much happening straight away. Just give it a little bit of a shake. Appears to be very slow to react. There's now a few little bubbles forming. I'm not sure if that's going to be visible on the camera, but yeah, it might have been better here to just use straight hydrochloric without diluting it, because that might be, the dilution of the hydrochloric might be slowing us down a little bit here. But it's a bit lazy to wait for that to warm up, so it's easier to add a little bit of easier to start with a little bit of boiling water just to get the temperature up. So you might be able to see now there's a little bit of a reaction going. I'll zoom in. and yeah, you can see there's a little bit of a reaction, going fairly slow, but yeah, I'll let that run its course and then see if I can see any more visible gold. If not, that would be a fairly bad sign, because if I can dissolve all of the visible gold with a 1/4 milliliter of nitric acid, then there's not going to be much gold in there. But let's let it run its course and I'll be back a little bit later. Okay, so as you can see there, and hopefully with the time lapse that you've just seen there, the reaction is pretty much stopped now, and we've got a pretty reasonable color to the solution there. It's obviously a little bit dirty, but it's not too bad. Now, as always, the problem that you get stuck with at this point is, and I should also say that I've put about 0.75, so 3/4 of a milliliter of nitric acid into there. So if it's unlikely that all of that was dissolving gold, there's probably some base metals that were dissolved by that as well. Otherwise, there'd be a pretty reasonable return, considering how easy these things are to process. But yeah, so as I was saying, the problem we've got now is I'm not sure at this point whether I've run out of gold in solution or whether I've run out of nitric acid. And really the best way to figure this out is to take a little pure gold button like I have there. Oops, see if it wants to focus. Well, anyway, got a little pure gold button. So what I'm going to do now is we're just going to drop that in there and see if that has any reaction. If there's no reaction whatsoever, then there is a reasonable chance that we've run out of nitric acid. If I do, and obviously you want to, like without saying, you want to obviously weigh your gold first to make sure that, just to know how much excess gold you're putting into the solution, because the other thing we're doing here is we're using gold to neutralize any excess nitric acid. Now, as you could probably see there, put some more light on top of there, I'm going to zoom in for you, but there is quite clearly, see if that's there, you can see all the bubbles at the top surface. There's quite clearly a reasonably vigorous reaction there, so I've definitely put too much nitric acid into this. And so what I'm going to do now is I've got a couple more, just zoom out again, I've got a couple more gold buttons like those. I use these for consuming excess nitric acid. I prefer this method now for denoxing over evaporation, because it's like you're not having to evaporate awful lot of stuff. It takes a bit longer sometimes, but you know, depending on how much you've got. But it's a very nice clean way to get rid of excess nitric acid. So we'll just leave those 3 gold buttons there now to get consumed, and judging by how vigorous the reaction is, it might put a half a gram or something like that into solution, so we'll see how that goes. But yeah, I'll come back when the reaction is stopped and I know that all the nitric acid has been consumed. Okay, so the reaction is now fully stopped there with the gold buttons, which means that there's no more free nitric acid in the solution there. And so the next step for me is going to be to add about 6 ice cubes to the solution there. That will serve 2 purposes. It will cool the solution down, which will precipitate lead, which is or lead salts, which are slightly soluble in hot water, as well as it will dilute the solution, which is going to be good to do that. So I like to do my denoxing and all that kind of stuff before I do any filtering. So there's only going to be 1 set of filtering that's going to happen now. Okay, I'll be back soon. Okay, now that the ice has cooled down that solution, we are going to filter it through a couple of filters into a large beaker that I will use for precipitation. Nice thing about this is the solution so far appears to be pretty clear. There's not much of the old
dreaded powder in this solution, so I might be able to precipitate this one straight away, but we'll see how things go once I finish the filtering. Okay, I'll be back soon. Okay, so unfortunately, if you have a look right there and there, you can see that I actually didn't quite dissolve all of that gold braze that was holding the silicon dyes onto the ceramic, but I'd say I got most of the gold from this, so good enough to do a test, but clearly I need to be a little bit more patient next time round. So what I'll do is I'll just have a quick look for any bits that obviously still contain some gold and just put them in if I do another batch of these. Okay, so here we have the solution that has been filtered from the ceramic memory chips from the large server boards, and what we're going to do is we're going to precipitate the gold using a few grams of sodium metabisulfite dissolved in some boiling water here. So I'm just going to give a little bit of a stir to the solution I'm going to precipitate. We're going to add the sodium metabisulfite, and hopefully we'll see a bit of a reaction happening there. Seems to be doing what I expect, so we've gone a little bit of a change of color there, and this is generally a good time to give it a stir. And then we just wait for a few moments and it should cloud up a little bit. I'm not expecting a super dark solution. Spray that down because we don't expect very much gold to come from only 20 of those little memory chips, but all things considered, that's looking okay. At least we are going to get something out of it. So now what I'll do is that'll just go on the back shelf and basically just sit there and settle for a day or so, and then I'll come back and wash the gold as well as weigh it. So I'll probably be back and finish this tomorrow. Okay, so here we have the resulting gold powder from 20 of those what do you call them, the ceramic RAM memories from those mainframe boards, and it's not very much. It should also be noted at this point that I put 0.1, so roughly 0.1 gram went into neutralizing the excess nitric, so whatever result we get we're going to have to subtract 0.1 from. So let's weigh it up and see what we've got. It's my existing gold that still needs to be melted. We're just going to zero that off, and then let's go for it. Let's hope for at least 0.2 to make it worth the effort. That is pretty fantastic. So if I subtract the 0.1 grams from that, we've still got roughly 0.5. That seems almost too good to be true. So if those things are returning about half a gram or so for 20 of them, and I have 30 times as many, that is a lot of gold. That could be in the like 15 grams or so. Amazing. Anyway, that's really good news for me. I didn't think that this stuff was going to return very much, and it seems like it's going to return pretty fantastically. So yeah, thank you for watching, and you know, if you come across some ceramic RAM, even though it's got those aluminium bond wires, definitely worth having a look at. See you guys next time. Have a good one.